Hello and welcome to the Science and Engineering Practices Teacher Toolkit. This toolkit is a reference guide for teachers in developing college and career-ready students. The last thing a teacher needs is more work. I get that. As a fellow Montana science teacher, I can definitely relate. It's my hope that this toolkit assists you in implementing the new K-12 framework with ease by helping you recognize current practices that already correlate. I also hope to spark some ideas that help you tweak current practices towards alignment. Upon completion of this toolkit, teachers will be able to identify when each science and engineering practice is currently being implemented in your classroom by examining what the practice looks like and how student understanding can be assessed. Let's first clarify the difference between science and engineering. Science and engineering are similar in that they both involve asking, developing, planning, observing, analyzing, computing, explaining, and communicating. They differ in that in science, one asks questions in order to develop some reasonable explanation, while in engineering, problems are defined or identified in order to design solutions. There are 8 science and engineering practices that are essential in developing proficiency skills in your students. First, you'll be introduced to the science and engineering practice and how it might look in your classroom. You'll then examine an aligned NAEP assessment question as it relates to each grade level at varying degrees of depth of knowledge needed to answer each question. Like I said, there's 8 science and engineering practices. They're shown here on this slide, and we're going to take them one at a time. So let's start with science and engineering practice 1, which is asking questions and defining problems. This practice in science is distinguished from this practice in engineering in that in science the student asks a question about an observation that leads to a greater understanding of that phenomena, while an engineer tries to make the observed phenomena better suited to sustain human needs. A scientist might observe a tub of blocks and ask, how tall of a tower can I build from these blocks? An engineer might look at these same blocks and say, so what can I use these blocks for? The outcome may be similar, but the scientist is seeking explanations and the engineer is seeking a practical application. A student's proficiency in science and engineering practice 1, asking questions and defining problems, progresses throughout their education. This ability begins before a student even enters school, to varying degrees, as students observe and experience the world around them in a manner that's unique to them. A teacher's role in developing this skill is to guide the students towards asking scientifically relevant questions as they pertain to real-world situations. For instance, a child could ask, which beak is best? And in order to lead your students to asking scientific questions, the teacher may ask the student to clarify their questions. With some communication back and forth, the student then may ask which beak shape is best for cracking seeds. As questioning skills advance, the student should develop questioning skills that lead to identifying variables. By grades 3 through 5, a student should be able to ask questions like, what makes a wide, short beak better for cracking seeds than a long, narrow one? Since this skill builds from one grade to the next, by grades 6 through 8, the student could then ask, is there a width to length ratio that's best suited for cracking seeds? And by high school graduation, the student should be able to work on developing an efficient nutcracker. Remember to look towards developing proficiency by developing skills in students that help them ask questions that are testable and falsifiable, and identifying problems that can be solved by asking these questions. The following slides include example NAEP test items. Each of the sample assessment questions included in the toolkits are released NAEP items. The questions were first identified as falling under one or more of the disciplinary core ideas in science, life, physical, and/or earth and space science. Then they are further aligned to the K-12 Science Framework Standards 1, 5, and/or 6, linked to the depth of knowledge needed to answer the question, and then correlated to each science and engineering practice at the Ahead of the Curve Riding the Wave 2014 workshop. This practice is most likely addressed in an assessment if a student can accurately identify the who, what, or how A student in grades K through 2 should be able to ask questions based on observations that can lead to further understanding and to identify questions that can be answered through investigation. The 3rd through 5th grade student builds on the K through 2 experiences in asking questions and progresses to specifying qualitative relationships. The 3rd through 5th grade student should be able to ask questions about what would happen if a variable changed, distinguish between scientific and non-scientific questions, and predict reasonable outcomes based on patterns in the data collected. In these examples, the K through 2 student needs to ask themselves how the shape of the bill assists the birds in obtaining food. According to NAEP, this is an easy question since over 80% of the students at this level are able to answer this question correctly. But the depth of knowledge required to answer it is at level 2, since the students need to apply basic understanding of the ecosystems in which each organism lives, as well as correlate this understanding to how it helps the bird obtain its food. The 3 through 5 assessment example is an easy grade 12 NAEP question, but the content is introduced in grades 3 through 5 in our K through 12 science framework standards. The 3rd through 5th grade student needs to define the relationship between forces, mass, and acceleration in order to answer this question, placing this question at a depth of knowledge level 3. In each case, the student must think more deeply about the question being asked in order to answer it correctly. The assessment measures the student's ability to apply basic understanding of scientific concepts. In grades 6 through 8 and 9 through 12, the student's ability to ask questions and define problems continues to build on previous experiences. By the end of 8th grade, the student should be able to determine the relationships between independent and dependent variables in experimentation, identify relationships in models, and clarify and or refine models based on observations. They should also be able to provide clarification of models and arguments from evidence collected, as well as ask questions that challenge the premise of an argument. By grade 12, the student should be able to ask questions and define problems that can be subjected to controlled experimentation, ask critical questions of data presented or arguments presented, and define systematic design problems. In this assessment item, that's aligned to both 6 through 8 and 9 through 12 life science core content, the 6 through 12 grade student must identify the who and the what as they relate to each system, and how the system in the body is related to the regulation and coordination of our functions. This question requires the student make connections among body systems. So they need to think more deeply than simply rote memorization, placing this at the depth of knowledge needed to answer the question at level 1. I realize that identifying suitable standards-based activities and assessments can be an arduous task. So instead of performing an exhaustive review of NAEP items that relate to the Science K through 12 frameworks practices as performed in the summer of 2014, you might consider exploring Next Generation Science Standards classroom sample assessment tasks. For illustrative purposes, I've included the Energy of Ocean Waves exemplar. Through reviewing this lesson, you might have a better lens to understand how you can take your existing materials and instead of starting from scratch, simply reworking the questions to meet the expectations of the practice. Each of the Next Generation Science Standards classroom sample assessment tasks can be found under the Resources link, which is in the Implementation tab at the top of the Science Standards main page. Each sample classroom task begins with an introduction. In this exemplar, the introduction includes a brief overview of how students may examine ocean waves to discover their physical properties of motion, explore the effects of this motion, and evaluate potential uses of these effects. This section is followed by a list of science, math, and language arts standards addressed by the task, and if it's in bold print, it indicates the portion of each standard that is addressed. In this activity, students hone their math skills as they develop the skills necessary to ask scientific questions and define problems in the energy of ocean waves. The next sections provide details necessary to implement your lesson. in your classroom, including possible modifications you could use, how to evaluate student understanding, and all the supplementary resources you need to actually take this lesson and implement it in your classroom, and other background information. Well, I hope this eases some anxiety in implementing the standards in your classroom and assists you in identifying those practices that you already address. Thank you.